Okay, so we're going to continue solving systems through elimination, just like last week. But last week, when we were solving systems through elimination, we were given opposites, like in this system here. Negative 4y and 4y are opposites. So we just add them. This cancels out. We solve. It's good to go. Over here, you see in this system, we've got 6x and negative 6x. Those are opposites, so they cancel. So we add them and, go along with our day. Well, we don't always have opposites. They're not always given to us. Look at this example of a system, okay? You'll see that the x values are not opposites and the y values are not opposites, right? This is like a -1. And obviously, -1 is not the opposite of 2. 4 is not the opposite of 3. So what do? Well, you make opposites by changing either the x or the y values to make them opposites. So we can change the x values, 4 and 3, to make them the same and then a different sign. Or we can change the y values to make them the same number with a different sign. Okay, so how do you do that? Well, you find least common multiples. Okay, so you want to know what number is the smallest or least number that your two numbers go into evenly. So with 4 and 3, those were your x values. Okay, those were the x values here. With 4 and 3, the multiples of 4 are 4, 8, 12, 16, 20. With 3, obviously, the multiples are 3, 6, 9, 12. I'm going to stop because I already now know that the least common multiple of 4 and 3 is 12. 4 goes into 12 3 times, 3 goes into 12 4 times. So I can multiply 4 times 3 to make it 12, and I can multiply 3 times 4 to make it 12. And then all I'd have to do is make one of these a negative. So I just choose to multiply this one, and you would get -12, and voila, opposites. Or you can look at the y values, okay? Remember, up here we've got the -1 and the +2. To me, that's easier because 1 has all kinds of options, right? You could do ×2 and get -2, ×3 and get -3, etc. And look, I already found an opposite. I didn't even have to do anything to this 2. All I had to do was multiply this by 2. 2 times -1 gave me -2, and -2 is already an opposite of 2. So I had to do less work here than I did here. So I'm going to choose to make my y values opposites because of that. Okay, by multiplying this number here by 2. Now, you can't just change one number. I can't just say, okay, I'm going to make this -1 into a -2. You have to change the entire equation to make it equal, to keep it the same. So you have to multiply this entire equation by 2, not just the -1y. Okay, so 2 times 4x is 8x. 2 times -1y is -2y. And 2 times 6 is 12. So all I did was take this first equation, I multiplied everything in the equation by 2, and it got me this equation. Now, if you look, this new equation is this one. So I'm just going to put a line through it for right now because it's not important. We changed it so we could have opposites, and now we do have opposites. So now it's just like last week. If you have opposites, you can go ahead and add. 3 plus 8 is 11. 2 plus the -2 cancels out. That was the whole point. 21 plus 12 is 33. And then you're just solving. So you get x equals 3. So now you know, though, that you need a solution, which is an x comma y. So now we still need our y. How do we find it? Well, we replace x with 3, and we're going to use the very first equation. So instead of 3x, we're going to do 3 times 3. So 3 times 3 plus 2y equals 21. Obviously, parentheses here, multiply. So 3 times 3, so we've got 9. Bring this down. Solve your two-step equation. So you get 2y equals 12, and then you divide by 2, and you find out y is 6. So now you think you have your solution, but please remember you need to check it. So check. Okay, how are you going to do that? You're going to replace the x value with 3 and the y value with 6, and you're going to use the other equation. We already used this. So we're going to use the other equation, but don't use this equation that you changed. Use the very original one that was given to you, because you could have made a mistake when you were multiplying and maybe this equation's not even right. So always use the originals. So I'm going to use this one. So instead of 4x, I'm going to do 4 times 3. And instead of -1y, I'm going to do -1 times 6 equals 6. Okay, so again, I'm replacing the x with 3 and the y with 6 in that first equation up here. All right, so 4 times 3 plus, oh, nope, sorry, that was a minus or a negative. 1 times 6 equals 6, okay, which is 12 and negative 6. And does 12 plus negative 6 equal 6? Yes. So your solution is correct. You checked it. You're good to go.